Hello students. So today discussion is about nature of matter. So to start the discussion students, what is matter? Like what is the definition? What does it mean by the matter? Matter means anything which has mass and occupies some space is called as matter. What does it mean by the mass? It should have some amount of matter in it. It should have some amount of weight, that is called as mass. As well as occupying space means it should occupy some space, right students? That is volume, having the volume, that is occupying space. For example students, this board, digital board, is it a matter? Yes, it's a matter. It has some mass, yes sir, it has some weight and it occupies some space. The fan, is it a matter? Yes, it's a matter. The book, is it a matter? The pen, the chalk, we are the part of matter or not? Yes, we are also matter. Our shadow, is it a matter? Her shadow is not matter, yes sir. Why? Because does it have any mass? Does it have any amount of matter? No, nothing. Does it occupy some space? No, don't think it is occupying, sir, it is occupying the space. No, it's simply a reflection, yes sir. No. So shadow is not a matter. So what is matter? Anything which has mass and occupies some space is called as matter. So this matter is anything mass and occupies space and can be perceived by our senses. In general, that is called as matter. And the study of the matter and its composition is nothing but chemistry, students. So this matter in this chapter we mainly will focus on how many classifications, how can we classify matter, in how many types the matter is getting classified into. So first of all, let's see some of the characteristic properties of matter. Matter is made up of tiny particles called as molecules. Ultimately everything is matter. The whole planet Earth itself is matter. Everything, all are matter only. Why? Because everything has a mass and occupying some space. So what this matter is made up of? Matter is made up of molecules. Okay, what molecules are made up of? Molecules are made up of atoms. Understood? The ultimate particle is atom. These atoms combined produces molecules and the combination of all these molecules matter. Understood? Can we see molecules? Very, very tiny particles. Can we see these atoms? Very, very tiny particles. As a matter, as a unit we can see, that's it. Understood students? So matter is made up of tiny particles called as molecules. The molecules in turn are made up of very small particles called as atoms. The smallest unit of matter is called as atom, the smallest unit. Understood? Right. The molecules are so small, they are not visible to our naked eye. We are drinking water, yes or no? We are drinking water. So we are using water in many ways. So can you see the water molecule? No, you can see a water drop. That water drop contains some trillions of water molecules. Just imagine how small the molecule is. Can we see these molecules with our naked eye? Can we influence the molecule with our naked eye? The answer is no. Understood students? So what is the formula of water? H2O molecule, yes or no? And what that molecule is made up of? 2 hydrogen atoms and 1 oxygen atom. So that's what everything, the whole matter is made up of. The whole matter is made up of water only? No. Different atoms, different combinations, different substances, different materials, different particles. Yes or no? That makes it all these different substances. So molecules of matter are in constant vibration. For example, if you're sitting on a bench, try to hit that bench. You can feel some vibration, yes or no? Or your school bell. If you hit on that bell, what you can see? You can see some vibration. That means the particles of matter in solid form, they undergo this vibratory motion. That means they keep on their own positions, they keep on emitting this vibratory motion. So all the materials occupy space and all material bodies have mass and hence they have the weight also. Ultimately matter has mass and it occupies some space, that is called as matter. Now let's see some of the classification of matter. Matter students mainly classified into 2 categories. One is on the basis of physical characteristics and other one is on the chemical properties. So matter mainly physical basis as well as chemical basis. On the basis of physical classification, we have almost 5 classifications here, 5 types of matter. Mainly 3 types are there in these 5. Solids, you already know, solids, liquids, gases. Mainly we study. We have the 4th state also, that is called as plasma, and 5th state of matter also we have the discussion, that is BEC, Bose, Einstein and condensate. Bose, Einstein, condensate. Total 5 states of matter. This classification comes under physical or chemical? Physical. Sir, why it comes under physical? That I'll explain. Just wait. You have to wait for some time. Now let's see. Another type of classification is chemical classification of matter. Matter under the basis of chemical properties, mainly two types. One is called as pure substances and other one is called as impure substances. That impure substance is also called as mixture. In these pure substances, again they are subclassified into elements, compounds. Elements are classified into metals, non-metals, metalloids and noble gases also. Everything, all the discussion we have in this video. So to start the discussion about physical classification of matter. Sir, why it is called as physical classification? What is the speciality? What is the difference between physical and chemical? First of all, the difference is, students, in physical classification, the chemical formula of the substance remains same. For example, we have solids, liquids, gases. Yes or no? Let us take an example with water, H2O. What is the solid form of H2O? Ice. What is the liquid? Water. What is the gas? Water vapor. What is the formula of water? H2O. What is the formula of ice? H2O. What is the formula of water vapor? H2O only. Understood? Is there any change in the formula? That's why it comes under physical classification. That means under this physical classification, the substance is same. The substance is same. Then sir, what is the difference? That is the difference we are discussing in this classification. So mainly solids, liquids and gases. How can we differentiate these three physical states of any matter? So mainly, students, how the particles are arranged. Particles means what? Atoms and molecules. In solids you can see every circle like a ball kind of arrangement indicates an atom or a molecule. It depends upon the type of substance. Yes or no? Here how all the molecules or atoms are arranged? They are very closely packed. Yes sir, that's what makes a solid. And here in the case of liquids, how they are arranged? They are somewhat medium, loosely packed. What about in gases? How the particles are arranged? Very loosely packed. I am saying particles. What's the meaning of particles? Atoms and molecules. That's what matter is made up of. Yes sir, no? If you are talking about water, we are talking about molecules, water molecules. How the water molecules are arranged in the ice? Closely packed. In liquid water, somewhat loosely. In gases, water vapor, very loosely. In the case of iron, we are talking about atoms. Iron is an atom. Yes sir, no? It's an element. So that's what the thing is. So the main property is how the particles are arranged. Solids closely packed, liquids medium and gases very loosely packed. And next, the main property which decides any element, any molecule, any substance to exist as a solid or liquid or gas is intermolecular force of attraction. The attraction between the two molecules, the attraction between the two atoms is called as interparticle force of attractions or intermolecular force of attractions. Now answer, students, in which physical state of matter these intermolecular force of attractions are more? That means attractions between the two molecules, where that is more? Of course, obviously solids. That's why so in solids the molecules are very closely packed. Yes sir, why? Because more attractions are there. That's what make them hold together and to form this solid cluster. Yes or no? The force of attractions are more in solids, little bit weak in liquids and very weak in the case of gases. That's why gases are freely moving, the atoms. Understood? Why? Because the force of attractions are very low. Next, the space between the molecules. Next property is the space between the molecules. This is called as intermolecular space. Where the space is more? Solids, liquids or gases? Space between the molecules, gases. Yes or no? In solids, very less. Liquids, medium. So this is intermolecular space. Next, the main properties which defines all these solids, liquids and gases is mass. Mass means you already know amount of matter, that is mass. Mass and weight both are same in chemistry, so don't confuse. So do solids have mass? Do they have weight? Yes, they have. Do liquids have mass? Yes, they have. Do gases have mass? Yes, they have mass. Understood? And they have fixed mass. Solids, they have a definite mass. Liquids have a definite mass. Gases also have definite mass. Sir, but why don't we feel the gas? Why? Because the particles are loosely packed. Understood, students? The particles are very loosely packed. They keep on moving here and there. That's why we can't feel. And we evolve in this environment to habituate under this, to exist in this gases. Understood? In this atmosphere. So that's why we don't feel the weight of all the gases. But gases also have mass. Is the molecule changing? Look at this molecule. Students, look at this molecule, here, here, here. In these three states, is the molecule changing? If the molecule is not changing, how the mass will change? The mass is not changing. Then sir, why is the solids are more weight? Why? Because all the particles are very closely packed. That gives more density. Yes or no? That makes it more weight. That doesn't mean the weight is changing for solids, liquid, gases. But for a particular quantity, solids, liquids and gases have same definite mass. Got the clarity about mass? Next, volume. Do solids have volume? That means occupying space, right? Volume, they have a volume. Do they have fixed volume? Yes, solids have a definite volume. Yes sir, no, solids have a fixed volume. Are the molecules changing, going anywhere? No. Do liquids have volume? Of course, all the matter have volume. Yes sir, that's what the definition of matter. Anything which has mass and occupies some space is called as matter. Liquids also have volume. Do they have definite volume? They also have a definite volume. For example, students, take 1 liter of water and pour that 1 liter of water in another glass. Now, there also 1 liter only, na? Take that in any bowl. There also 1 liter only. The volume changes? No. Understood, students? The volume of liquids is fixed. They have a definite volume. What about gases? Do they have volume? Gases have volume. Do they have fixed volume? The answer is no. Gases do not have fixed volume. If you take that gas in a balloon, they simply takes the volume of the balloon, occupies the volume of the balloon. If you take the same gas and you fill it in the cylinder, they occupy the volume of the cylinder. By then they have any fixed volume? The answer is no. Understood? And in the closed conditions, they are taking the volumes of that particular containers. In open conditions, do they have any volume? No. Why? Because these molecules are keep on moving. Take a glass. Can you say particular amount of volume of gas in it? No, you can't say. Why? Because the molecules are changing. Yes or no? They're coming and going simply, continuously happening. Understood? That's why gases don't have a fixed volume, indefinite volume. Right? Next, shape. Solids have shape, particular shape, right? All the solids we are saying different types of arrangement. Solids are the wall, everything, this board, everything. We are also, of course, we are also not solids. We are all made up of solids, liquids, everything. We have next liquids. Do they have fixed shape? Liquids takes the shape of the container, right? Fixed volume. But if you take the liquid in a cup, they takes the shape of the cup. In a bowl, shape of the bowl. In a glass, shape of the glass, right? And what about gases? They also don't have any fixed shape. Why? Because first of all, they do not exist there only. They keep on moving and they keep on changing. So these are main physical quantities to differentiate a solid, liquid and gas. Interparticular force of attractions, intermolecular space, mass, volume, shape. Now density. What is density? Mass per unit volume is called as density, students. Mass per unit volume. Sir, what is mass? Let's say molecules per unit volume. Molecules per unit volume. You already know what are molecules, right? Unit volume means I am taking this much of volume. How many molecules are there? 4. How many molecules are there? 2. How many molecules are there? 1. Yes or no? Now, where in small space where there are more molecules? In solids or liquids or gases? In solid. That means solids have more density. Yes, sir. Density is not thickness, students. Density is not thickness. The number of molecules present in a unit space is called as density. India is the densest country. Why? Many people are living per square kilometer. And America is the least densely populated. Yes, sir. Why? Well, less number of people are there per square kilometer. So it depends upon how many molecules are there per a unit space. That defines the density. So where there is more density, solids have more density, followed by next liquids, next gases have very least density. Got the clarity? Next, compressibility factor. Compressibility. So can we compress solids? Students, we can crush the solids. We can break the solids, but we cannot compress. Why? Because compressing means what? We have to make the molecules move together very closely. Already they are closely packed. Yes or no? How can we move? We can break the molecule. We can break not the molecule. We can break the substance. We can break the matter. Chalk. If you do it, what will happen? It will break. Does it mean compressibility? No. Solids can't be compressed. What about liquids? You can see in liquids there are some spaces, yes or no? Under some high pressure we can compress liquids or not? We can make these molecules to occupy this empty space or not? Liquids are little bit compressible. What about gases? Gases are very easily moving, freely moving. There are a lot of empty space between them. If you provide high pressure conditions, we can compress gases to large extent, highly compressible. Understood, students? They are highly compressible. Next, diffusion. Diffusion factor means, students, simply the movement of molecules from one place to the another place, from higher concentration to the lower concentration. That is diffusion. Do solids undergo diffusion? No. Do they move? Add sugar and salt. all the sugar molecules move and enter into the salt molecule? They will not move, they will there only. Yes or no? We have to mix it. So, but solids can diffusible under liquids. Sugar in water, all the sugar particles can mix in water. Yes or no? So, diffusion property for solids is a little bit less, but liquids and liquids undergo diffusion clearly. Yes or no? Milk, water can easily mix up. What about gases? Gases have more empty spaces. They can easily undergo diffusion. For example, smoke. If you lit any smoke, or perfume, if you spray perfume, it can easily spread throughout the room. Yes or no? So, that is what the diffusion property. So, next, fluidity, flow. Do solids can flow? Do not flow. Yes or no? Sir, I can move. It is no. That is not. That is not fluidity, students. They have ability to flow. Do liquids flow? Yes, liquids flow. From where? From higher area to the lower area they can flow. What about gases? Gases move in all the directions. They have high fluidity. Yes or no? So these are main properties which defines a solids, liquids and gases. What about which particle? Iron. Iron in solid state, iron in liquid state, iron in gaseous state. We are not comparing iron in solid state, liquid in water in liquid state and something other in gas state. Any substance can exist in three physical state. How does it exist? That also we have the coming discussion. So this classification of matter comes under physical classification of matter, students. So fourth state of matter. Fourth state of matter is called as plasma state. Almost universe, 96% of the universe mostly occupied by the energy, dark energy, and this plasma only, students. Plasma state means highly energetic particles, super excited particles. They are called as plasma state. They contains very high energy. For example, sun, that is plasma. All the stars are burning, yes or no? They are plasma state only. So that is the fourth state of matter. In general, in the chemical discussion, we don't have this plasma state. Mainly, you have to concentrate solids, liquids and gases. We have fourth state also, that is called as Bose-Einstein condensate. This is developed by the Einstein as well as Satyendranath Bose is an Indian scientist. And what is this BEC, Bose-Einstein condensate means, students? It is if you lower the temperature to very cold conditions, almost absolute zero. That means almost minus 273 degrees Celsius, which is also called as 0 Kelvin, also called as absolute zero. At that temperature conditions, this matter is behaving like independent atoms. What I said, matter is made up of molecules. Molecules are grouped together, sir, that forms matter. But these matter is behaving in like independent atom. That state is called as fifth state of matter, which is BEC. Can we observe this BEC under normal conditions? Means the answer is no. Under only experimental conditions, special conditions, if we can maintain that condition, we can able to see this BEC, Bose-Einstein condensate. So, like I said, you have to concentrate mainly on solids, liquids, gases. I hope you got the clarity, differences between all the three physical states. Next, interconversion of matter. Interconversion of matter means, is it possible to convert solid to liquid, liquid to gas, gas to liquid, liquid to solid again? The answer is yes. How to convert? By energy, students. How to convert? By energy. In the differences, I didn't explain about energy. Here we have the discussion about energy, like which has high energy, solids, liquids or gases. We have the discussion. First, melting process, students. Look at here, solids to liquids to gas. First, what is melting? The process of conversion of a solid to liquid is called as melting process, and the temperature at which this process is taking place, that is called as melting point. For example, ice. Ice is a solid, yes or no? When it converts into liquid water, 0 degrees Celsius. What is the temperature? 0 degree Celsius. So what is the melting point of ice? 0 degrees Celsius. The process of conversion of ice to water is melting. By process it is called as melting, and it is happening at a particular temperature, yes or no? That point is called as melting point. Okay, so do all the substances, do all the chemicals have same melting point? Do all chemicals melt at 0 degrees Celsius only? No. Different chemicals melt at different temperature. For example, sodium chloride, it melts at around more than 800 degree Celsius. So that is its nature. Ultimately, what is happening? If we are breaking the force of attractions between the molecules, yes or no? How a solid converts into liquid, liquid converts into a gas. Simply the molecules should expand. How they expand? You have to heat it by heating process. Sir, what is happening when you heat it? They already have intermolecular force of attraction, yes or no? These force of attractions will be broken and they expand. More heat energy, more broken and they expand. And how to do the opposite process? Cool down. If you cool down, what will happen? The molecules comes closer, they develop force of attractions. More cooling down, then they're more closely packed and ultimately it becomes into solid state. So that is the process, students. Melting process. Next, boiling. I'll explain about evaporation just wait. Boiling. What is boiling? The process of conversion from liquid to gas is called as boiling. That means, let's take an example, water to water vapor. Yes or no? And that process takes place at a particular temperature or not? What is the boiling point of water? 100 degrees Celsius. Yes or no? 100 degree Celsius. So the temperature at which a liquid changes into a gas is called as boiling point. So if you're mentioning the specific temperature, that is called as boiling point. And these boiling points, these conversion temperatures for different substances, they have different values, right? Next, sublimation. What is sublimation? If a substance changes from solid state to gaseous state, that is called as sublimation. Opposite is reverse sublimation, desublimation. These different names are there. So what is sublimation? When a solid directly changes to gas. What are the examples? Dry ice, solid carbon dioxide, yes or no? What happens? It directly converts into gaseous form. If you order ice cream, students, sometimes you'll get this dry ice, some ice cube kind of thing. They are not ice, that is dry ice. What it is made up of? Carbon dioxide in solid form. Can it converts into liquid? No, directly because of this temperature, directly converts into vapor. So naphthalene balls, yes or no, we used to do in the for the clothes or everywhere. They are also undergoes sublimation. Ammonium chloride undergoes sublimation. Iodine undergoes sublimation. These are some of the examples which undergoes sublimation. Next, evaporation. Students, evaporation, also the process of conversion liquid to gas, is called as evaporation. Then what is boiling? Liquid to gas only. What is evaporation? Liquid to gas only. Same process, why different names are there? The reason is, students, boiling takes place at a specific temperature, but evaporation takes place at all the temperatures. I will explain, listen. What is the boiling point of water? 100 degrees Celsius, yes or no? What does it mean? At 100 degrees Celsius, water converts into, liquid water converts into vapor, right? Yes or no? Now here at the room, we have room temperature which is 25-26 degrees Celsius. Is there any chance for the presence of water vapor at these conditions? No chance. It should exist above 100 degree. But water vapor is also present here. Sir, what is the proof? Take a glass, add ice cubes. You can see water droplets outside the glass. Why they form? When this water vapor in the air, when it touches, when it cools down, it forms water droplets. Water vapor is present here. Why? Below 100 degree, how there is a chance for presence of water vapor? It should present after 100 degrees Celsius, no? The reason is evaporation, students. Sir, why evaporation takes place? The reason is, students, molecules, for example, let us take a beaker with some water molecules. So these water molecules undergo forces of attraction. Sir, many billions and trillions of water molecules are there. Which water molecules undergo more force of attractions? Between surface molecules or bottom molecules? Here in bottom molecules, yes or no? Surface molecules, do they experience more force of attractions? The answer is no. Right? So that's why surface molecules, they experience very less force of attractions. With limited energy only, these molecules gains the temperature and simply they escape into the atmosphere, molecule by molecule, layer by layer. That's why when you drop some water on the floor, can you observe that water after half an hour? After 1 hour? No. What is happening? Are we maintaining 100 degrees Celsius in the room? No. Then where this water is gone? Evaporation. Each molecule by molecule, it escapes into the atmosphere. This condition, this process is called as evaporation. At what temperature it happens? At all the temperature, from melting point to the boiling point of water. Understood, students? Got the clarity? So this process is called as evaporation. Next, opposite process, from gas to liquid, it is called as condensation, and liquid to solid, the process is called as freezing. Remember, this process from solid to liquid to gas, the process takes place by heating. What about the opposite process? How does it take place? By cooling. Yes or no? By cooling, all the molecules come closer, develop force of attractions, and gas converts into liquid, liquid converts into solids ultimately. Is the formula changing? When solid changes to liquid, liquid changes to gas, the formula is not changing, the formula is constant. That's why this classification comes under a physical classification. Otherwise, we would have called it as a chemical classification. So right, next, classification of matter on chemical composition. Now we have the chemical composition. Now let's see students, on chemical composition mainly matter is classified into two types. One is pure substances and other one is mixtures. In the previous slide I have shown you the main classification. Now look at here, on the basis of chemical, how the matter is classified, pure substances and mixture. I'll just give the clarity about pure substance and mixture and then we'll discuss all the points. Pure substances means students, the matter have only one type of property. What are pure substances? Matter have single type of property. Sir, what is the property? What is the meaning of property? Its physical state, its melting point, boiling point, its smell, taste, odor. These are physical properties. Chemical properties, its reactivity, how it reacts with oxygen, with acids, bases, everything. It has only one type of property for each, that is pure substance. Sir, then what is mixture? It has different properties, that's it. Yes or no? I'll give the example. Oxygen is there. Oxygen, is it pure substance or mixture? Oxygen is an element, yes or no? It has its own melting point, it has its own boiling point, it has its own taste, it has its own color, whether it is tasteless or colorless in general, I'm saying. It has its own color, it has its own densities, right? It has its own chemical reactivities, everything, right? That is pure substance. Next, sodium chloride in water. Sodium, salt in water, salt solution. Is it a single property? No, it is mixed with two compounds or not? One is sodium chloride and another one is water. Sodium chloride has its own melting point. Water has its own melting and boiling points, yes or no? If they mix, do they form any new substance, single substance? No, that is mixture. Understood student? That is mixture. Milk contains water, proteins, carbohydrates, different substances are mixed or not? That is mixture. Got the clarity students? So that's the difference between a pure substance and mixture. In this chapter we have mainly focused on pure substances, types of pure substances, everything. So pure substances are mainly classified into students two types. One is elements and compounds. Elements are further classified into metals, non-metals, metalloids and inert gases. Let's see first of all, element. What is an element? Define an element. From the beginning we are talking about all matter is made up of atoms, yes or no? How many atoms are there? How many atoms are there? That's a question. Is it possible to count? Infinite number of atoms are there, yes or no? Now the question is, are all these atoms same or different? All these atoms are not same, they are different. What do they differ by? They differ by subatomic particles, electrons, protons and neutrons, yes or no? So all these atoms are not same, they are different, right students? Definitely we classify them or not? This classification of atoms is called as element, meaning atom with one proton is called as hydrogen element. The only one atom is there? No, don't think sir, you said only one atom with one proton only. No, atom with one proton means all the atoms students in the universe, at least on this planet earth, with one proton each, all comes under first element. That's a classification. All atoms with two protons each, second element. All atoms with three protons each, third element. Fourth, fifth, like that. How many elements we have? 118 elements. How can you define an element? Atoms with same number of protons is called as an element. Atoms of same type is called as an element. So these elements like hydrogen, oxygen, nitrogen, sulfur, these elements are different. Yes, sir, no, they have different properties. So based on these properties, we have further classification: metals, non-metals, metalloids, and inert gases. First, metals. So what are metals, students? Metals are lustrous in nature. They are shiny in nature. Iron, shiny. Silver, shiny. Gold, shiny. Copper, shiny. All metals are shiny in nature. Yes or no? So all metals are solids at room temperature. In general, they are like whatever the examples which I gave so far, they are all solids or not? They are solids. They are good conductors of heat and electricity. These metals, these elements are good conductors. They conduct electricity. Why? Because they have some free electrons. These free electrons are the reason for the conduction of heat and electricity. Metals are malleable, ductile and lustrous. I already explained about lustrous nature. Malleability means, have you seen aluminium foil used for food wrapping? That is malleability property. For example, your school bus, what it is made up of? The body, the school bus body, what it is made up of? Or car, at least car body. It's a metal, right? How it is made into that? Can you make carbon with like that? Can you make oxygen like that? Can you make anything other element? No, you cannot. Only metals are malleable. That means making an element into very thin sheet is called as malleability, and next ductility. Ductility means making wires. Can you make coal into wire? No. Oxygen gas into wire? No, right? Yes or no? So that is ductility. You can make iron wires, copper wires, gold wires, right? So metals are strong. They have high tensile strength. They can withstand high power also. So they're very hard substances. Most of the metals are hard, like, okay, metals have high densities. Of course, they are obviously solids means high densities only. Metals are sonorous in nature, that is metals make sound when we hit an object, not just making sound, students. When you hit the metals, they make ringing sound. For example, school bell. If you hit that, how it will be heard? Like some vibration, right? That is ringing sound. If that any object makes a ringing sound, that is metal. So these are all the properties which defines metal. And what are non-metal? Simply opposite: non-malleable, non-ductile, non-sonorous, non-metal, right? Some exceptions are there. All metals are solids but except mercury. Mercury is the liquid metal at normal room temperature. Gallium becomes liquid above 30 degrees Celsius. If you hold gallium at our body temperature, it becomes liquid. Zinc metal is not malleable, non-ductile at the normal temperature also. In general, metals are malleable, ductile, but not zinc. So it depends upon its arrangement of atoms. Some metals like sodium and potassium are soft metals. Even they can be cut with a knife also. Metals are in general hard, but sodium and potassium are very soft metals. Even we can cut a metal with a knife also. These are exceptions. Exceptions are very, very important. You have to remember. Next, non-metal, students. What are non-metals? Non-metals are not hard. Like I said, completely opposite to the metals. Non-metals have dull surface. They do not shine. Most non-metals are soft solids or gases. Like carbon, does it have any shiny nature? Carbon? No. Sulfur, powder, yellow powder, does it have any shiny nature? No. So oxygen, it's a gas, yes sir, obviously. So in general, non-metals they have dull surface, they do not shine, they are soft. Solids are gases. Non-metals also exist in solids, liquids and gases. Solids means carbon, sulfur, iodine, phosphorus, these are solids mainly. And gases means hydrogen, nitrogen, oxygen, fluorine, chlorine, these are gases. Liquid, there is one liquid non-metal, that is bromine. Only liquid metal is mercury, only liquid non-metal is bromine, right? Next, students, metals are non-ductile, non-malleable, but non-metals are non-malleable, non-ductile. Non-metals are brittle nature. Brittle means easily break. Yes sir, carbon, sulfur, they can easily break. So that is, they break into pieces. Non-metals are bad conductors of heat and electricity. They are not sonorous. They do not produce any ringing sound. So they are also bad conductors. Why? Because non-metals always show tendency to gain electrons. Metals always show tendency to lose electrons. So that's why metals conduct. Non-metals do not conduct heat and electricity. Exceptions are there. Graphite. Graphite is an exception. It is an allotrope of carbon. It's a form of carbon. It can conduct heat and electricity, students. And bromine is a liquid non-metal. Examples of non-metals: carbon, oxygen, sulfur, hydrogen and nitrogen. These are non-metals. Next, metalloids and inert gases. Metalloids means, student, the elements which have the properties of both metals and non-metals. They are called as metalloids. So look at the examples: boron, silicon, germanium, arsenic, antimony, tellurium and polonium. These are called as metalloids. So where we can find these metalloids in the periodic table? So when these metals are converting in the periodic table, all the elements were arranged, yes or no? So you can see the line of elements clearly differentiate, clearly separates metals and non-metal. These line of elements have both properties. These are called as metalloids. And inert gases, the last part of the periodic table, last group in the periodic table are inert gases. So what is the speciality about these inert gases? They are chemically unreactive. All the elements are almost all are reactive, but these inert gases also called as noble gases. They are unreactive elements in the periodic table. So these gaseous elements which do not combine with any other elements or even themselves also, they exist as independent atoms. They are called as inert gases. Examples: helium, neon, argon, krypton, xenon, radon. These are noble gases. So these type of elements are there. How many types? 4 types of elements are there. Next, atom and molecule. In the beginning discussion only we completed this part. Once again, what is an atom? The smallest unit of matter is called as an atom. What is a molecule? These atoms, because atoms are reactive, yes or no? All these elements are reactive, right? These atoms combine chemically and they form a molecule, right? For example, H2O. Hydrogen atoms, oxygen atoms combine in a proper ratio, they form H2O, which is called as molecule, students. So we have the list of molecules here: O2, H2, Cl2, N2, H2, NaCl, CaO, NH3. Students, identify the difference between this set of examples and this set of examples. What is the difference? All these are molecules only, right? They're combined only. All these numbers, subscript numbers indicates number of atoms. O2 means 2 oxygen atoms. They're combined molecules only. What's the difference? Here, same elements combined, there different elements combined. Yes or no? These are called as molecule of element. They are called as molecule of compound. That's it. That's the difference. Molecule of element and molecule of compound. So molecules are two types. Next we have compound, the same. When different elements are combined, that combination is called as molecule of compound. H2O, is it a molecule of element or compound? Answer, it's a molecule of compound. Hydrogen and oxygen. Sodium chloride, molecule of compound or molecule of element? Sodium different element, chlorine different element. Ozone, O3, molecule of element or molecule of compound? It's a molecule of element. 3 are oxygen only, na students, right? That's it. So we have this list. Sodium chloride, and main point here for the discussion about these compounds is, students, this is a main point also, remember carefully. Sodium chloride, it is made up of sodium and chlorine, right? Does it have the properties of sodium and chlorine? Sodium chloride, does it have the properties of sodium and chlorine? What's your answer, yes or no? If your answer is yes, you are absolutely wrong. The answer is no. If it has the properties of sodium and chlorine, it is having different properties. It should comes under a mixture, yes or no? How come it comes under a pure substance? Remember students, remember when elements are combining to form molecules, when atoms or elements both are same, combine to form molecules, that molecule doesn't have the properties of its elements. Water, H2O, made up of hydrogen and oxygen. Does it contain hydrogen properties and oxygen properties? Absolutely no. I'll give an example. See, sodium is an explosive metal. When it is dropped in water, it explodes. We are simply adding salt in water with lime juice, simply with drinking lemonade, yes or no? Are the sodium atoms exploding from sodium chloride? No. Pure sodium explodes. Chlorine is used as a disinfectant, but chlorine is a poisonous gas. It is also used in the World War times also, students, to kill the enemies. But we are adding sodium chloride in all our dishes, yes or no, for cooking purpose. Are we getting poisoned? No. What does it mean? It doesn't have the compound, a molecule doesn't have the properties of its element, what it is made up of. Remember, main point. So salt, different names are there. Different names definitely for everything, for every compound should be called by a particular name. Salt, sodium chloride, these are the common names. These are the scientific chemical names. Baking powder, sodium bicarbonate, NaHCO3. Vinegar, CH3COOH or acetic acid, this is the condensed formula. Sugar, C12H22O11, sucrose. Chalk, calcium carbonate, CaCO3. Bleaching powder, CaOCl2, students. Calcium oxychloride or calcium oxychloride, it's not hypochlorite. Next, gobar gas, methane, right? Next, battery acid, H2SO4, sulfuric acid. Quicklime, CaO, calcium oxide. Sand, silicon dioxide, SiO2, sand. It is made up of silicon dioxide. So these are all the compound, students. Compound comes under pure substance only. It comes under chemical classification of matter. Don't forget the order. Next, the last type of chemical substances. About this we have much discussion in the next chapter. So, but I'll give the clarity. I already gave the clarity. Impure substances. What does it mean by impure substances? Like salt adding into water. Is it pure or impure? It is impure. Why? Because different substances are there. Different properties are there. Yes or no? That's why. If any solution which have different properties, more than two or more than two substances are present in that, that is called as a mixture. So when two or more substances combine in a proportion, then that resultant substance so obtained is called as a mixture. We study about the mixture in the further classes. And remember, combining means they are not combining chemically, they are combining physically only. Sodium chloride is not reacting with water, yes or no? If it react with water, what will happen? It should produce a new compound. New compounds are getting produced? No. Got the clarity? Adding water in milk, water is reacting with milk? No. That physical combination is called as mixture. Students, I hope you got the clarity about this chapter. Very, very important chapter. Basics about all the atoms, molecules, metals, non-metals, physical classifications and chemical classification. More about mixtures we'll discuss in the next chapter, students. Thank you.